video, electrostatic. I'm Courtney, and today I'm representing a proton, and this is, where'd she go? Hold on. This is Emily, and she is in our electron today, and we're going to explain electrostatic for you guys. Alright, let's get this started. Like I said before, today is all about electrostatic. You might be asking yourself, what is electrostatic? Well, if you want to hear the, more complicated, sciencey, smart way of explaining it, it's a branch of physics that deals with the phenomenons and properties of stationary or slow-moving electrocharges. That's complicated. So more simply put, electrostatic isn't the kind of electricity that most people first think of. The kind that runs all of the stupid electronics that are running our lives, but it's the little bit of charge that makes your shirt stick to itself or makes it possible for you to shock your favorite sibling after you rub your sock-covered feet across the carpet.
Okay, so now before we can really get into a discussion about electricity, one must cover the charges. So charge is the property that determines the interaction between particles. There are three types of particles, which we should all know of electricity, which is your proton, electron, and neutron. And the protons, of course, are the positively charged ones. And in this video, Courtney here is represented, again, by the proton, and I am the electron. Paper. And there, again, is also neutrons, which are like Switzerland, which the Switzerland part of the world, which, if you're clueless about history, means they're neutral, because neutrons are completely balanced and they don't have a charge. In electricity, the term opposites attract become quite literal. Protons are The protons are drawn towards the electrons, while electrons happily accept the protons, sometimes. Two positives, or two negatives in a sense, they will avoid one another like the Black Plague, because they don't go together. And the two charges do not like to chill with one another. So, we're going to demonstrate in our next scene about how they look whenever protons go to protons, negatives go to negatives, and a proton and electron go together.
Alright, so this is what happens when a positive and a negative come near each other. Yay. Ooh, attraction. Yeah, we're stuck. Yes, we like each other at this point.
And then the next one is a negative and a negative. Whenever they come together, bye!
Oh.
They repel against one another. And it's the same thing for a positive and a positive.
If
So,
you kind of try and, nope. Okay.
Bye-bye.
Alright, so that's what the interaction of the particles are, as demonstrated by us. Okay, we're moving on. Alright, so all of these particles are reacting to each other, and it's called an electric field. The charge of a proton is moving outwards, as shown in this diagram. Alright, move it a little closer so they can see everything. Yes, good. Alright. And the charge of an electron is moving inwards, as shown in this picture. All over again. Okay. Alright, and this is why electrons and protons react to each other the way they do. They complement each other and create a natural flow of energy, as shown here, into the electron and out proton, and if it's neutral, in negative, out positive, all of that. So that's electric fields for you, and Emily will end it off for.
Okay, so in the beginning, an example that we gave for electrostatics was clothing sticking to itself. This is commonly known as static cling. Another example of such a cling is that you're likely to be familiar with is with how a balloon sticks to the ceiling after being rubbed on someone's head. In this scenario, the rubbing of the balloon causes it to be charged. The ceiling is neutral, and that is until it comes in contact with the balloon. At this time, the ceiling experiences something called charge polarization. This is the shift in positive and negative. Also, you can relate that to a microwave. And in response, it's an external electrical charge. In this example, the balloon is negatively charged, so the ceiling reacts to that by making the area touch the balloon positively charged. This change of charge creates an attraction, making the two stick together. And that's how it works, how the balloon sticks to the ceiling.
So this unfortunately is the end of our time together, for this is the end of the video. So now you know all you need to know to have a basic understanding of electrostatics. So we bid you farewell, and good luck with all of your scientific endeavors. Anything to say, Em?
I'm just glad this is finally over.
This electron might have become a little too negative. Oh well, don't let her get you down. And just keep learning like the geniuses you are. Because, like always, science is fun!
Yay.